Class 9 Higher Mathematics, chapter number 4, Logarithm. In this chapter, we are going to study the laws of indices, at the same time how it is related to logarithm. Then after that, we will go to the definition, then we will compare the exponential form and logarithm, then we will go to the examples, then we will try to prove some of the important laws of logarithms. Now let's go to the introduction part. Now this is a symbol that we know. A to the power m is usually read as a raised to the power m, or briefly a to the power m. Here a is called the base. Now this a is the base and this power is the exponent on the power. Now these are the 1, 2, 3, 4. These are the laws of indices. So these will be used in developing the laws of logarithms. That means based on these laws of indices, we develop the laws of logarithm. Now let's see the definition. For a positive real number a, now let me highlight this. For a positive real number a other than 1, this number a cannot be 1. If a happens to be 1, then the relation does not hold good. So that one will be explained later. Now let's go back to the definition again. For a positive real number a other than 1, if a to the power m is x, then we define that logarithm of x to the base a is m, and we use the notation log of x to the base a equals to m. Now this is the logarithmic form and this is the exponential form. Now you see here, these are the now we have 1, 2, 3, 4, 1, 2 statements here, and you can, these are all exponential form. You can convert into logarithmic form. Now how to express, I'll tell you. This one, in the first case here, a is the base and m is the exponent, and this is the number. So this is a relation. And if you want to express this exponential form in the logarithmic form, it is like this. This base will be still base. The only thing will be this power and the number will be interchanged in the form of logarithm. So power become the number, and this number in the exponential form will be the log. Now see, a to the power m equals to x. Then in case of logarithm, base is same a here, and this number we are going to take log. Then this power will be the value of the logarithm. The same is the case for this also. Now log of 8 to the base 2 is 3. Now it is the log of 8, that means this number log of 8 to the base 2 is 3. Now you can try out for the remaining exponential forms here. So I am just leaving this one, the blanks, for your practice. Now let's go to this. If the bases are same, then if the bases are different, see, you can see the base is 2 here and the base is 4 here. For the same number, if you take logarithm of different bases, then the values are different. Now you can see here, same number 16, we are taking log, but the base over here is 2 and over here is 4, so the values are different, the reason being this one. Now let's go to this example. Find the logarithm of 6 to the base cube root of 6. Now this value we have to find. So logarithm of this, so this one, let this particular value is what we have to find. So this value that we are to find, let us take it x. So let log of 6 to the base cube root of 6 be x. Now this is the exponential form. This is the logarithmic form. So let us first express this in the exponential form. So base is cube root of 6. Now we are writing base cube root of 6. What is the power? This number x. So we are writing x here. Then this value 6 will be here. Now this exponential, this is a radical sign. This radical form can be, this radical form is just expressed in the fractional notation here. The power becomes 1 by 3. So now when you open the bracket, these two powers will be multiplied together according to the laws of exponents. So we have this 6 over here. The this side 6th power is 1, so this power, this left side is x by 3, so x by 3, and this side, right hand side, the power is 1, so x by 3 equals to 1. So you take cross multiplication of this 3 to this 1, 3 and 1 will be multiplying, then you have x equals to 3. So this is the value of this logarithm. Now let's go to this example 2. Find the base if the logarithm of 3 is minus 1. So we have to find the base. So let a be the base. So the logarithmic form of the given expression will be log of 3 to the base a is minus 1. This is according to the question given here. Then this logarithmic form, let us convert into exponential form. A power minus 1. A power minus 1 will be the number here, this one. So a to the power minus 1 means 1 by a. So you take cross multiplication or you take the reciprocal of this, then you can get a equals to 1 by 3. So the base is 1 by 3. Now let's go to question number 3, example number 3. If log of x to the base a is m, so that log of x to the base 1 by a. Now here is a and here is 1 by a. So if you change the base from a to 1 by a, then you will have minus 1 here. Now let's see. We are starting from the given condition here. The left hand side we are taking. So log of x to the base a is m. Then let us express this in the exponential form. Then we have a power m. A power m will be x. A power m will be x. This is the exponential form. Now let us take this a reciprocal, then you take minus 1 again, so that it will become a. So if you take 1 by a reciprocal, it is nothing but this is a. So this a can be expressed as 1 by a to the power minus 1, and the other remains the same. The power m is here and this value x is still there. Now let's open the bracket. This minus 1 and this m will multiply and it will get minus m, and here is 1 by a. So let us apply the logarithm. So log of this number x to the base 1 by a. To the base 1 by a is the power. Power means over here. So now this is the laws of logarithms. These are very important. We have 4 laws here, and this will be used in solving your problems. Law number 1. Now you can see here multiplication of two numbers. In case of logarithm, we are just converting into addition. So this is one of the powerful method that is we are using as a tool to solve problems. So instead of multiplication, you can solve as addition. This is in case of logarithm. Ordinarily we have to multiply two numbers, so instead of multiplying we can simply add the numbers, then the problem becomes very simple. Now how it is, let us see. Let you take the right hand side, these two terms as one as x and one as y here. So log of m to the base a will be taken as x, and log of n to the base a will be taken as y. Now see, then this one, this logarithmic forms is just expressed in the exponential form. That is, a power x will be m. A power x is m. A power y will be n. A power y will be n. Then let us multiply these two expressions. Let us multiply so that we can get m into n. So a power x, a power y will be multiplying. A power x is m. We are writing m here. A power y is n, so m into n. So multiplication of a to the power y and a to the power x will be this one. So whenever the two bases are same, according to the laws of exponents, we have the powers added, y and x and y will be adding together. So a to the power x plus y is nothing but m into n. Then this exponential form is just convert into logarithmic form. So that means log of m into n. Say log of m to n, what base? Base is a here, base a equals what? The power is here. This is by the definition of logarithm. So let us restore back the values of x and y. That is, putting back the value of x and y, we get the first law. That is, x is x over here, x is over here, and y over here. So this is your first law. Then second law. In case of second law, division becomes subtraction. So instead of dividing, we can simply subtract it and we'll get the result. Now let's see. The same is the case as in law 1. We have to take this first one, the right hand side of the first term. The first term of the right hand side will be x, and this second term will be taken as y here. So let log of m to the base a be x, and log of n to the base log of n to the base a is y. Then we have this exponential form. Now let us divide. A to the power x by a to the power y is m by n here. A to the power x by a to the power y, m by n. Now again let us apply the laws of indices. This a and a bases are same, so we have to subtract the powers, x minus y. So we are just applying the laws of exponents. Whenever two numbers of the same bases are dividing one another, then you have to subtract the powers here. Now this is the exponential form. Then you can convert easily to logarithmic form. Log of this number, that is log of m by n, base is a here, then the power here. So you just restore back the values of x and y, and you will get the second law. Now let's move to the third one. Log of m to the power n of base a. Log of m to the power n base a is nothing but this n. This n will be coming in front here. That means log of m to the power n of base a is nothing but n times of log of m to the base a. Now let's prove. Now we have to take this one, log of m to the base a is x. We are taking this log of m to the base a is x. Then let's back to exponential form. So a to the power x is m. A to the power x is m. Then what is a? Again, sorry, let us take the powers. This side and this side power is power n, both sides. This power also power n, this also power n. Let us take powers of n on both sides. So a to the power x to the power n, m also raise power n here. Then you open the bracket, then x and n will be multiplying together, and then this is the exponential form. Let us apply the logarithmic form, and we have log of m to the power n to the base a is xn. The value of x, we are writing back the value that we have taken before, then we will get the result. Now from the three laws above, we see multiplication. Multiplication is replaced by addition. Then division is replaced by subtraction. Then evolution or involution or evolution is, that means raising of powers or extraction of roots is replaced by multiplication. So these are the advantages that we have in case of logarithm. Now very important law that we have is law number 4, that is change of base. So we have mainly two types of logarithm. One is common log and one is natural log. Sometimes natural log means the base over here